Hello folks, welcome to the first part of my series on building a NavMesh-based character controller. In this video, we will lay the foundation by setting up character movement, rotation, and a flexible input handling system that will keep everything clean and modular as we go. Later, we'll cover animation, inverse kinematics, and a prediction system that smooths movement and animation by anticipating the controller's future. Let's get started. First, we install Unity's new input system. Next, we create an empty game object. Let's call it Input Handler. We add a player input component, then drag in our input actions. We also need to set it to invoke Unity events. We create another empty game object. Let's name it Player Controller and add a cylinder to it. Let's also remove the collider for now. We'll quickly build a test area and bake our NavMesh, and nothing happens. That's because we didn't mark the test area objects as static. Let's try again. Perfect. Next, we create an input handler script. Then, we attach it to our input handler object. Finally, we map the player input to the handler script input. We create a controller script. We add a function for receiving raw vector2 input and another to handle it properly inside the update function, where we smooth the input. We also need a reference to the controller inside the input handler. Now, all that's left is to attach the controller script to our player controller game object, reference it inside the input handler, and we're good to go. All right, now it's time to get the controller moving. First, we create a function that calculates and smooths the controller's speed using the smoothed input. Then, we add another function that uses Unity's NavMesh.samplePosition method to ensure our controller stays on the NavMesh. Finally, we add it to the update loop. Now we can test our code, and the controller doesn't move. The code looks fine so far, and that's because the problem lies with the actual controller game object. The controller is floating above the NavMesh. Let's lower it onto the NavMesh and raise the capsule model to keep it looking right. Perfect. But it's still not quite right. Let's zoom in and check it out in slow motion. We can see that colliding with the NavMesh border doesn't affect the controller's speed. It's just the NavMesh.samplePosition function that keeps it on the NavMesh. First, let's create a NavMesh.raycast and remove the normal projection. Much better, but as you can see, it's still not quite right. We can improve it further by creating a collide and slide type of function. Apply it to the move vector. Let's try again. This looks a lot better now, but there's still room for improvement. We can start by modifying the collide and slide function to break out of the loop earlier if it's used on an input vector and return a 0 vector. Finally, we have something that looks decent. Before we actually address rotating the controller model, let's create 3 actions using the system library, one each for movement, input, and rotation. Then, we'll replace our current update code with these actions and initialize them inside the start function. These will come in handy later. We write a simple rotation function, add a face to our capsule, and now we have a rotating model. We're halfway done. Go sip some coffee or tea, stretch your legs, take a quick lap around your apartment, take a moment to soak it all in. Or just keep watching like the game developing madman that you are. All right, let's continue. Now we need to set up our actual input handling system. Let's start by creating a stack class and a stack item class. We add some basic constructors to the stack item class, along with getters and setters for its data. With that out of the way, we can go back to our stack class and write a push function to actually push data onto the stack. We also need a function to pop the top of the stack and a way to clear the stack completely. Finally, with a few public getters in place, our stack is ready to go. Before we create our input handler system, we first need a class to hold our input functions. With that done, we create our input propagating scriptable object. It uses the top of the stack for input, ignoring the rest until the top is popped. This makes input handling simple, even in complex projects. Next, we write functions that use the top of the stack to propagate input. And finally, we use the scriptable object inside the input handler script. We create a scriptable object instance and drag it onto our input handler. And now, all that's left is to implement this inside our controller class. Drag the input scriptable object onto the controller game object, and our controller will use the new input handling system. To test the power of this system, let's first create a test script that holds references to our controllers alongside the input scriptable object. Now, we can duplicate our controller, but first, we need to move the camera out of the controller object so it doesn't get duplicated too. Let's add more inputs to our system and map one of them to trigger the switch chars function. Let's test the changes. And it's a mess. This happens because we never actually cancel the old input after pushing something new onto the stack. We also need to stop the controller from pushing input to the scriptable object to avoid duplicate entries in the stack. Now that everything's working, let's push the system further by creating a mock-up UI that pushes itself onto the stack once opened and pops the stack once closed, simulating, for example, opening and closing the in-game menu. Let's also block the character switch while the UI is enabled. Finally, all that's left is to quickly set up the mock-up UI and test the changes. There you have it. Our input system is done and ready to be used and modified however you see fit. And that wraps up this part of the series. In the next episode, we'll take things even further, making the controllers collide with each other, using the rotation action to change how the controller rotates based on external influences, and setting up the future prediction system that we'll later use to smooth out both movement and animation. All relevant project files will be available for free on our Gumroad page. Cheers, and see you in the next part of the series.